Welcome, everyone. My name is Olya. I lead developer experience at Rootstock Labs. Rootstock is the first and longest running Bitcoin sidechain. What makes Rootstock special that it is fully EVM compatible. So as a developer, you can write all your smart contracts in Solidity and also enjoy the expansive EVM compatible toolchain. We've created this particular series, Mastering Developer Tools on Rootstock, to walk you through some of the super useful integrations and tools to make sure that you are equipped for building on Bitcoin with Rootstock. Today, we have a wonderful project with us. We're talking about Gelato, in particular Gelato functions, and we have Anirudh joining us. Welcome, Anirudh. It's really great to have you here. Let's start with a quick intro.
I'm Anirudh. I do developer relations here at Gelato. And yeah, happy to be here. Thank you for having me, Alia. Yeah.
Listen, sweet. Maybe tell us a little bit about your journey. How did you get to work in DevRel? How did you get to work in developers, in particular in Web3?
Right. So I think I started off as an intern. I graduated about 1.5 years ago. And yeah, Gelato seems to be one of the first jobs which I took on. And yeah, it has been a great experience having to talk with a lot of customers, big customers like, roll up as a service, middleware customers. So yeah, it's been an amazing experience. And basically, my Web3 journey started back in university. I was just on YouTube, like everyone else,
All
looking
right.
at Patrick Collins, just hacking on stuff. And that's how I got into Web3. And yeah, here I am today. So yeah, happy to be
Yeah.
here.
Very cool. Yeah, no, really good to know. Gelato is probably one of the first podcasts for kind of Web3 dev I've ever listened to. I randomly came across it and just remember thinking, oh, that's really cool. So that was years ago or so before I started working in Web3. But cool. Yeah, well, without any further ado, let's talk about Gelato. What is Gelato?
Yep. So Gelato is a roll-up as a service platform. We manage, deploy, and service roll-ups for our customers. On top of roll-ups, we also do provide. This is something that Gelato only provides, which is a unique value prop as well, which is a suite of middleware services for our customers, which allow users like, Gelato Web3 functions, which we'll be diving into today. And then we have Relay, which we'll have a workshop tomorrow by Javier. And then we have VRF as well, which allows users to get verifiable randomness. And the good thing is that all these middleware infrastructure is also deployed on Web3 functions is deployed on Rootstock as well. So yeah, excited to see how builders, use it and how they can automate. So that's in a nutshell what Gelato is. Yeah.
Yeah, that's super exciting. Automation, always cool. All right. Should we go through a little presentation that you have for us today to maybe dive into some of the details of how it works and how developers can use it?
Sure, let's do it. I'm gonna go ahead and share my screen, Anirudh, and today we are diving into something that's changing how smart contracts operate, and that's Web3 functions on Rootstock. So now we all know that smart oracles are powerful, but they have this one major limitation, right? Which is they can't really trigger themselves. So they need some sort of that they're waiting for a transaction to do something, right? But what if we could automate them? What if we could make them react to like real world events, price changes, what if we could make them react to even off chain data, right? And this is where Gelato Web3 functions come in. That's what it will help you guys build, which is a fully decentralized application which you can automate without even relying on centralized servers or bots, right? So by the end of this video, you should have like a good understanding of what web functions are, how you can write them, how you can deploy them, and how you can run them. So yeah, let's get started. So yeah, okay, a quick introduction about myself, although we already did one. I'm Anirudh. I do developer relations at Gelato. And in this workshop, we are going to be talking about what are Gelato functions. So we'll be diving into all the three functions that are available, which is TypeScript functions, Solidity functions, and an automated transaction. We'll be taking a look at some of the security considerations that you should have because it's important to know how Gelato function calls the target function in your contract. We'll be also taking a look at how payments work in the scenario, right? So I'll be explaining you what OneBalance is and how it works and how it simplifies how simplifies making payments for running automations on all supported networks, including Rootstock. And yeah, we'll be having like a live workshop with demo, some live code to show you how you can how you can build this yourself as well for your protocol or for your app. So yeah, let's get started. All right. So what are functions? So functions are Web3's leading smart contract automation solution, right? So what does this mean? So basically, you can react to on and off-chain events. You can access any off-chain data and computation or even APIs. There's also advanced monitoring. Maybe I can show you like a quick glimpse of the UI as well before we dive right into the workshop. So it gives you an understanding of, what all you can monitor, right? So you can monitor, let's say, the logs, the transaction hashes, the executions, right? And yeah, it's available on 30 plus networks, right? And also customers like, MakerDAO, a PancakeSwap, Ostium, Beefy, they're using these tasks, these Web3 functions in the production environment within their app to automate these tasks. And I think that's like super interesting use case. So yeah, and how does this work? So basically, these are just three simple steps, right? You just select your trigger, and that means you can select a trigger like time interval or cron expressions. This could also be, you can also trigger this task that you're making every block, or you can have it react to an on-chain event. And the next thing would be to define what to run. You can either select between a capture function, a Solidity function, or an automated transaction. Last thing, you just have to ensure that your OneBalance is topped up with USDC. OneBalance is our gas tank, which allows you to sponsor transactions on all supported networks, and make sure your task is up and running. And this will just trigger your task based on the conditions and the configurations that you've set. So it's super simple, super straightforward. Yeah, let's dive right into it. All right, about the implementation path, how would you go ahead and implement this? Is that firstly, you have to think about how often would you like to trigger your run, right? So this, like I previously mentioned, this could be a time-based trigger. This could be an event-based trigger. This could be a trigger every block, right? And based on these triggers, you can actually mix and match, right? So basically, what you have to do is next step would be to decide what to run, right? So you can have capture functions, Solidity functions, and transactions. As I mentioned, you can mix and match this thing. So you can have for every block, you can trigger a capture function, right? For every time, you can trigger a Solidity function. So yeah, basically, there are all sort of combinations. You can choose any. Then the next step would be to decide how you like to create the task. Basically, there are three ways of creating a task. You can do it via the UI, via the SDK, or via the smart contract. And the last thing would be to obviously finalize and monitor these things just to ensure that things are working as expected, and yeah, everything is working according to your needs. And the automations are running and tested to your target contract. Perfect. Let's dive right into.
Thanks so much. I have actually a couple more questions that we can talk at the end, maybe about like the difference between and kind of how to get started and some concrete examples. Just directly before I forget, we were just talking about the balances, and you showed us OneBalance. So I just had a very simple question, as in if you have your function set up and your balance goes like below the required, what happens then? How do you keep it like up to date so that you don't get any errors and everything runs smoothly?
That's a really good question. So we allow users to turn on notifications as well. So we do provide notifications via your emails, via the app itself. So you can actually configure the app to send out notifications based on your balance as well. And once it reaches that minimum threshold, it will send out alerts to you guys. And also, let's say you're not actively checking out, we'll be also actively reaching out to you guys that, hey, your balances are low, right? Please top it up. Otherwise, your operations might be affected. So yeah,
Exactly.
that's how that works.
All right, cool. Yeah, thank you.
Perfect. Great question though. Thank you. All right. Before we get started, I would like to show you how the end product, that the end task would look like. So this is an example of a capture function. As you can see, this is an example of a Solidity function. And as you can see that I have this checker function implemented. Maybe we can quickly look, I'll be showing you this code as well, regardless, in the ES code. But this contract essentially has the checker function, right? And this checks and returns the conditions for this this Solidity function to execute. And it doesn't require any arguments over here. And it actually calls a target contract with increased count. And that's how it works. And over here, as you can see the UI, you can see the executions over here. We can see the task logs, like, all right, it was submitted. Currently, the task is paused, but we'll be recreating this for this workshop again. So this is an example of a Solidity function. And for a TypeScript function, we're going to be creating, like a simple oracle, right? Where we can detect the event from this contract that we have called the get price event. And based on this, it will then trigger this IPFS store logic, which is written in TypeScript, right? So what this essentially does is that it will get the price from the CoinGecko API and will then call the Oracle contract again with the payload that we want to submit, right? And this is based on the event that's emitted on the contract itself. So as you can see, there was an execution over here. We had this execution. So we're going to be building this as well. This is an example of an event-driven TypeScript function. So yeah, these are just two things that we're going to be looking into building right now. We're also going to be seeing how we can test it, how we can, how we can test it locally as well. So yeah, let's dive into the coding snippets. Cool. All right. So this is the GitHub repo. You should be able to directly clone this, and you'll be shown with this UI, right? So this is basically a hard hat project. All the configurations have been set for you within this project as well. So if you take a look at hard hat config, the Rootstock testnet should be already part of the config as well. Before you get started, make sure that you have your private key and Rootstock RPC URL set up as well, even provider underscore URLs for the sake of testing. So essentially, you can have the same RPC endpoint over here and over here. So yeah, I think that's important as well before you get started. And yeah, I'd just like to quickly walk you over the configurations that we have. So if you're not used to hard hat, this is the configuration. Over here we have set the Rootstock testnet. For the sake of this demo, I'll be running everything on Rootstock testnet. And I also added some configurations about the Blob Scout Explorer, the Explorer itself. So this will allow you to verify your contracts once you deploy them. Yeah, I think those are the two main components. Yeah, the chain ID 31 for Rootstock testnet. I think that should be pretty good enough for you to get started with the initial configurations. Right. So firstly, I would like to start off with Solidity functions, right? So maybe we can take a look back at this Solidity function. So over here, I have this function called counter resolver UT, which has the checker function. So let's take a look at this real quick. All right. So basically, I have what this contract really does is that it needs a constructor to initialize the counter contract address. So this is when deploying the contract, I initialize it with the counter contract, which is in this scenario, this is going to be my target function. And then I have this function to check if increase count function can be executed and prepare the payload. So how does the increase count function look like? Let's take a look at the counter contract real quick. It's a very simple contract, right? So this contract, it inherits the automate ready. There are two functions, there are two variables over here, count and last executed. And basically there's this increase count function. And as you can see over here, it uses only dedicated message sender. And this is the message sender that we talked about in the security considerations back when I was presenting the slides. And all it does is that it increases the count by the amount, and it updates the last executed variable with the current block's timestamp, right? And yeah, basically this checker function, it returns a Boolean, so true or false, and some bytes for the payload, right? So let's say we can get the timestamp of the last execution from the counter contract, so when it was last executed. And the condition over here I'm checking is that if it has passed more than 180 seconds, then it should exec, then it should return true, and then it should, prepare the payload to increase the count by 1, So this is like a very simple Solidity function. And yeah, these are the two main things. So obviously you can adapt this to your needs for your contract. So obviously, to sum it up, you would have to ensure that you have a checker function and you have a target function, which in my case is the increase count function. Keep in mind that this could obviously be in the same contract as well. So let's say if I go ahead and if I do, like function, function increase count over here, you know, this could ideally be my target function as well, but that's also possible, right? So you can have the checker function as well as the target function within the same contract. That's not an issue, right? So that's like a quick summary. And in this case, you're only going to be using Solidity functions. So this means that it's all going to be Solidity based. And in our example, we're going to be using the UI to create the task. So let's first deploy these contracts. Actually, I've deployed these contracts already, but maybe I can quickly show you on how you can deploy these contracts yourself as well. So firstly, let's just spin up, a new terminal instance. And obviously, please ensure that you have the Rootstock configuration set. How you would deploy these contracts is that I make use of the plugin called Hardhat Deploy. And what that means is that you can actually prepare scripts for your contracts, and they look something like this. So we have the script for counter resolver WT, and we have the script for counter, right? So to deploy. And how you can deploy is that you can, yarn hardhat. So I'm using yarn. So firstly, when you first get started, make sure to run the yarn install. And then maybe you can do yarn hardhat deploy, tags with the counter. And then maybe you can do network as for me, I've set it as Rootstock testnet. And then this should allow you to deploy the contract on Rootstock testnet. So for me, it's just going to return the same address because I've already deployed it. And the good thing is that I can head over to my deployments folder and I can actually check all my deployments in Rootstock testnet. So over here, as you can see, my current deployment address was 0x2f and it ends with 471c. So 0x2f and ends with 471c. And I've deployed counter resolver WT as well, and it's deployed at xe3 and ends with 08PD. And it gives you all the information as well. So this is how you can deploy the contract using Hardhat. This is just one of the approaches which I prefer. Obviously, there are other plugins out there as well. But I think this is easier because you can go back to your deployments folder and see the addresses that you have deployed already. So it actually saves it for you. So now that this is done, now that we've actually looked at counter resolver, our checker function, we have also looked at our target function, and we also deployed these contracts. Let's go ahead and try to create the task on Gelato UI. For the sake of the demo, in this case, I'm going to be creating a task on the UI. And I think that's like the simplest way to get started. But obviously, you can head over to our docs as well and see how you can use the SDK or, how you can create tasks for your smart contracts as well. Obviously, happy to help as well if you need any integration later on. So yeah, so this is how the UI looks like. So we're gonna be in our functions. So make sure you log in with your MetaMask wallet or any wallet of your choice, and you can head over to functions and you can create a task, right? And for this scenario, I'm gonna be running this task. Let's say every 5 minutes because I just want to show that the task will be executed. Actually, let's do it every 1 minute because it just saves time for the demo. And I want to run a Solidity function, right? And I want to start this task immediately as soon as the task is created. So what do I want to do over here? I want to create a task on Rootstock testnet, right? And the checker function over here would be my counter resolver WT. So if I head over here and if I copy this address, I can paste it over here. this should automatically fetch the ABI for me, and I can actually check that I have two functions over here. One is the checker function, one is the counter function. I want to make sure that my checker function is the checker function. You can name this something as something else as well, but just ensure that it's returning the data that's expected by Gelato. And lastly, we would require the target smart contract address, and in this scenario, this is going to be my counter contract. And I'm gonna paste this over here, and this should ideally fetch the ABI, right? And I can select increase count. So just to sum it up, I currently have my checker function contract over here and my target function contract, which increases the count. And lastly, I can just name a task. So I'm just gonna call it, Solidity function, Rootstock workshop, right? Rootstock workshop, run, let's say. Right, and I can create a task. Something to keep in mind is that you obviously need to have some funds. You can get it from the faucet as well. There's a faucet available. Maybe we can link that down in the description as well. I think that would make it easier for you to get some funds. That's where I got my funds from. So yeah, you can just click on confirm, and this would create a task for you. So as you can see, there's a transaction pending, and this is going to create a task on chain. And you can also check, and this will take some time, maybe about depending on the chain itself, so about 10-15 seconds-ish. And then this should ideally spin up the task itself. So let's give it some time to spin up the task and this automation. Transaction is still pending. Maybe we can take a look over here. All right. Cool. So yeah, so the transaction went through and we have our task over here as well. As since we created a Solidity function task, this is denoted by an SOL beside our function name, our task name essentially. And let's take a look at our task logs. So as you can see that the checker function actually indeed return, for the first scenario at least, it did return true. Basically, the logic is that the checker function checks that if the timestamp stored is greater than 180 seconds, if so, it will execute. So in our case, if that was the case, and the transaction went through, we can also check the executions as well. Maybe we can take a look at the execution right now. So this is the execution. This is how it looks like. So if I head over to my target contract as well, let's see, this is my target contract, and let's try to look it up on the Explorer. And if I take a look at my internal transactions, you can see that this is the Gelato function calling over here. And you can also see that the count is updating. So right now count has been updated to 4. And yeah, this is a very deep dive into how you can create Solidity functions yourself. So yeah, that's Solidity functions in a nutshell. We can take a look at task log again, because I knew that this time it wouldn't really go through because the condition would be false. So as you can see, the resolver in this case, the checker function in this case returned false because I'm running task every minute. However, my checker function expects the can exec true to be true is when it has more than 180 seconds, right? So that's why it returned false. So now this will be executed in the next run because that's going to be 3 minutes, right? So 180 seconds is 3 minutes. So in the next run, it will be executed. And that's how you can create a task, Solidity function task on the Gelato UI, right? So that Solidity function concluded. Let's try to build a TypeScript function now. I'll close this terminal and I'll restart everything from scratch. So for TypeScript functions, I'm going to be making use of, as I mentioned in the presentation earlier, I'm going to be making use of Event Oracle. And this is also a very simple Oracle contract, which I implemented. It's super easy to understand. What we have over here is that we have an Event Oracle contract with 2 public variables, one called the update count and one called the price. And there is this one event called get price event. And what happens is that we can, let's say I would like to emit an event just for the sake of this demo, right? So I have implemented this get price function, and all it does is that it just emits the get price event, right? And based on this, ideally, we would want to call this update price function. And what this does is that it takes price as an input parameter. It will then update the count by the price, and it will then just emit the price updated event with the updated count and the price. Right? So this is a very simple contract. Obviously, you can deploy this yourself as well. Let's just try to use the same command. So we have yarn. I've created a script as well. You can use this as an example. So this is a deploy script. It doesn't take in any input, parameters because there's no constructor arguments. So you can do yarn hard hat run, yarn hard hat deploy, and then you'll have the tags. So the tags would be event oracle, which is defined over here. This showcases that we would only like to deploy this specific contract, but you can just run a yarn hard you can just run yarn hard at deploy, and this would essentially just deploy all contracts at once. But for this scenario, we just want to deploy this specific contract. So event oracle, and we would like to deploy this on the Rootstock testnet. And this should, since I already deployed it, obviously this will give me the same. All right. So for the TypeScript function, basically we have this, all the TypeScript code which you implement should be within the Web3 function repository, within the Web3 function folder. And within this, you can create like the name of your Web3 function. In my case, it's simple event. Right. So let's say if you create another folder in Web3 function, let's call it, Rootstock, workshop, just for the sake of this demo, right? So this would essentially mean that this is a new Web3 function. And basically it should follow this structure within the Rootstock workshop as well. So some important components that you need to have is index. Right? So you need to have index.ts. You also need to have the schema, the storage, and the user args. But I would say that the user args and storage are mainly for testing locally. But yeah, you can have it. But the schema would definitely be important. So you can have schema.json as well. So yeah, that's how you would do it. I'll just quickly show you how my current Web3 function looks like. So yeah, let's take a look. So here is how my TypeScript function looks like, right? So I'm using the Web3 functions SDK with the event context because I would like to make sure that I'm triggering this function every event, right? And I'm using the contract. So in this scenario, I'm using ethers, right? And I'm using KY for API calls. And yeah, this is like a simple human readable API. So, right. So this is from the function itself. So we have get price event and we have update price. And how you implement this, that you can do a Web3 function .on run. So with the on run handler, it will execute all this logic given that the get price event is emitted, right? So from the context, you can get the user args, you can get the chain provider as well as the log. But then you can set the provider as the multi-chain provider. Then you can, and then this is the Oracle address. So in my case, it's 0x7P8053. So let's take a look. It's this one exactly. So I just use this contract as part of the Oracle address. I can also pass it as part of the user args, right? But that's something that you can decide as well. I'll explain you more about the user args as well, but let's take a look at the code first. Then what I want to do over here is that I want to get the current price from CoinGecko, right? So I have set this user args to accept some sort of currency. And then basically I run a try catch and I call the CoinGecko API to get the price, and I just store it, right, in the price variable. And lastly, I just return this to my Oracle. And lastly, I just return this to my Oracle with the updated price feed with the price as my call data as the payload. So this is an example of how a TypeScript function is implemented, right? Let's take a look at the schema. So in this schema, I have user args. There are currently two user args in this scenario. So we have the currency, which is accepted as a string format, and we have the Oracle, which is also accepted as a string format. And then we have the user args over here. This is just for the sake of testing locally to see if your Web3 function executes locally and it's working fine. So currently I've set the currency to Ethereum and my Oracle address to the deployed Oracle address, which I just deployed on Rootstock. So since there are two user args, it will look like this. And then since it's an event-driven Web3 function, I can actually mimic the log as well, which is emitted. And based on this log, it's going to check and it's going to trigger the run, right? So this is like a very deep dive overview of how you can implement. So obviously, to sum it up, you need to make sure that all your logic lives in index.ts, right? You need to have the schema.json with your defined user args if you have any. You can also use storage.json as well. In this scenario, I'm not really using the storage, but you can actually store some sort of data in the storage as well. And you can use user args as well. This would mean once you create a task, you can actually have it configure, inputs. You can have some customized inputs for your task as well. So let's say you want to spin up 10 different tasks with 10 different currencies. Just update the currency, just update the Oracle address, assuming you're deploying it on Rootstock and Rootstock mainnet, right? So this would mean that two different Oracle addresses, right? And this is where this use args feature is useful. Cool. So yeah, let's try to test this out locally. Just gonna take a look at index.ts. How you would test this out locally is that firstly, you have to ensure that your provider underscore URLs is set up, and obviously your Rootstock RPC. That's important. For the sake of local testing, I would use provider underscore URLs, right? And how you would test this is that you would use yarn w3f test. At least that's the command that I use. And basically with this, you can use, and then now you would have to point to your index.ts. So this would be a Web3 function, simple event, and index.ts, right? And I would like to check the logs, and I would like to simulate it at chain ID equals 31. And how did I get this chain ID equals 31? You can use chainless, or you can actually head over to the config and see that the chain ID of Rootstock testnet is 31, right? So let's try to run this command real quick. Cool. So over here, we can see like the Web3 function built successfully. We can see that it uses the user args that we have defined over here. So in our user args, we have defined Ethereum and it uses this address. And then it actually gets the updated price from the API itself. So these are the logs. So if you see that, if you head over, as you can see that I'm console logging the updating price with the price. And this is the price that we get from the CoinGecko API. And we can see that the return value is true. And this is the call data to our target contract, which is 0x7b, which is the same as this one. And this is the call data that we are sending out to our target contract, right? So this is how it works. If you want, you can actually extract the logs as well. You can do this via this code. I'm not really using this for the sake, but I just wanted to showcase it just for the sake of the demo. So you can actually get the logs as well, and you can actually extract the data from the log and use it in your function if needed, right? So that's also possible. So anything that's possible in TypeScript should be possible within the logic that you implement in your TypeScript function as well. So yeah, that's like an advantage. And now that we have tested how this works locally, right? So next step would be to deploy this to IPFS. And how you do this is that you can use a yarn hardhat deploy. And you point this to a pre-function, simple event, and index.ts. And this should, sorry, I think I made a mistake. It should be yarn w3f deploy. So maybe we can cut this out. So yarn w3f deploy. And then we have a pre-function, simple event, and index.ts. And this would actually go ahead and deploy your code to IPFS. So as you can see, given this command, we got the IPFS CID, and we also got a link to create the task. So we can copy this and we can use this as part of our task creation via the UI. So let's get back to the UI again, and let's try to create a task for this event trigger on Rootstock testnet. So yeah, you head over to create task, right? You go to on-chain event, and on Rootstock testnet, first you would have to input your contract address in which you're listening for the event from. So it's going to be the event oracle, right? So I'm going to listen for this contract. It should fetch the AVI, and I'm listening for the get price event, right? And I would like to trigger a toucher function for this on-chain event, which I've just deployed. So over here, it will ask me for the IPFS CID. I can just copy this CID as well. So I can copy this as well. And it's asking me for my user arguments, which are actually defined in the schema. So obviously I need Ethereum as part of the as my user args, and I would like to use the same contract, which is 0x7B. What's the issue? I'll just write it down. ATHERU. Let's see if that's correct. Args, I'll just copy paste this just to ensure that I've not made any typo. All right, no typos over there. And yeah, actually, you can set secrets as well. In my case, I'm not setting any secrets, but if you like to use secrets, you can actually go ahead and define them over here. Lastly, I would just go ahead and say, all right, event, I'll just like to name my task. So event-driven Rootstock workshop run, right? And similarly, you would create a task. I've checked everything looks. This is the UI. You can click on create task and you can head over to on-chain event. And you would use your target contract. In this case, it's going to be the event oracle contract, right? So you copy this and you paste this over here. And you select the get price event with the toucher function and with the IPFS CID over here, right? And the currency I would like is, as defined in my user args, I would like Ethereum. And I would like my oracle address to be the oracle. And I can just call it, test event rootstock test that oracle, right? Let's see. All right, waiting for confirmation. Let's confirm. And error occurred while creating a task in Tural JSON. Not sure what's going on with this. Maybe I can show the task once again that I've already created. So I have this task created over here. I'm not sure why am I getting RPC errors on Rootstock testnet. Interesting. All right, so as a backup, I already created the task. I'm not so sure why I was getting an error, but this is how ideally the task is supposed to look like. It's with the same configurations, and it's using OneBalance as mentioned. So this is OneBalance. I'll maybe walk you over more about how this works.
Yeah, that like it's fine. It happens all the time. So I think once you can have it when after you show it, and then we can just jump to and you can just say, oh, let's have a look at the task and just show the task. Like
Sure. Also, I think there's something wrong because my event oracle transaction is still pending. I'm not so sure if there's a problem with the RPC itself, the public RPC for Rootstock testnet. Let me check if it's producing. 2 minutes ago, and then now it's 1 minute ago. Okay, but that's all right. All right, so yeah, so this is the task that's created with the Ethereum and Oracle, right? And maybe we can go ahead, and I've actually written a script as well. So with this script, you should be able to trigger the function. So you can just yarn hard hat run scripts. And then I can use get price on network rootstock test that, right? And this should send out a transaction to my Oracle address, which is over here. Let's see if we get returned with the transaction hash. All right, so the get price event was emitted, right? We can take a look. And then over here, this is the event that was read from the contract. So if we head over to our event Oracle contract, we can see that there was an event, a get price event, and we can take a look at the logs. So a get price event was emitted recently. And based on this, we actually ran all this code ourselves, this logic of updating the price. And this is the execution. So let's take a look again. Let's try to refresh. Let's try to see the the internal transactions, contract, read, write. Can check the price. It's 2295. So let me check. So although the task was submitted for execution, I think we're waiting for it. Right. So here's the execution. As you can see that the task was actually submitted for execution. So it's currently 7 p.m. for me. I'm on Bangkok, and this is the execution transaction hash, right? And this way just updated the contract with the logic that we have implemented for the Thatcher code. So yeah, that's like the end of the demo for Thatcher function as well. Let me just quickly show you about OneBalance as well as how you can get a dedicated message sender. So this is how the OneBalance UI looks like. And then you can deposit from Circle with USDC, you can deposit USDC. And you can actually check all your transactions over here as well. And in order for you to get a dedicated message sender, you can actually head over to settings and you can get dedicated message sender for Rootstock testnet, even for Rootstock mainnet. So it's going to be the same address over here because it's EVM, but it could be different. It's best to check it first before you implement it and, don't just try to copy it from one network to another. So yeah, that's pretty much the demo. And yeah, thank you so much. And yeah, if you have any questions, yeah, I'll be happy to help. Yeah, that's pretty much it. Thank you.
Thanks. That was super interesting. I love the simplicity of the examples and the code snippets that you showed. It really was really easy to understand, and I'm sure folks have enjoyed watching it. What I was going to ask you is, I think what made it super easy to understand that you had this super simple use cases, like an Oracle, for example, that we've just gone through. Could you maybe share some other ideas in terms of the functionality that people can, when they just getting started with Gelato, that they can build up like some actual like real use cases or examples that they can look into?
Yep. So I can, yeah, maybe let me share some more examples. So I think one of the most popular use cases would be in DeFi actually. So this is where DeFi protocols actually use it for, rebalancing, for reward distribution. So I think that's like the number one use case. After that would be obviously you're pushing prices on chain as well. So if you take a look at like PIT, for example, you can actually push prices with that as well. And now, we're actually introducing, Gelato oracles as well, which will allow you to just create this task on the UI itself directly. So oracles is obviously one of the most important use cases, and that's the reason why I decided to show it. So DeFi, we have oracles as well. And then for pushing prices, and I think, yeah, these would be like the top two use cases that we have. Other than that, I think if you would like to explore more use cases, we have a GitHub repo with all the use cases listed. Maybe users, if you're watching this, you can go ahead and check that out. But also the live code of that we have shared for customers as well. So yeah.
Oh, nice one. Yeah, that was actually my second question. That's really cool that you mentioned you've got a bunch of repos. I also was going to ask you if, for example, people just hacking around and trying it for the first time on a hackathon or kind of like in a time constraint event rather than, really implemented it in a project, whether there is any reference that they can follow. But it sounds like you've got all it's all on GitHub, so people can just go and browse repos and just take it from there. Is that correct?
100%, yeah.
Nice.
Just go ahead, clone it, and just run it.
Right, perfect. Nice. And then what about developers? I know Gelato has quite a big, friendly international community with people sharing code. What's the best way for devs to join and maybe get some feedback or maybe find like fellow devs for specific projects? Is it Discord or maybe some events? Could you share some ways to get in touch?
Yep, sure. So we do have channels open on Discord. I'm active there as well, also on Telegram. So we do have this community chat on Telegram. We do have a chat on Discord. I'm active there. I can help out. I can reach out. We do have a few of the DevRel teams member as well that will actively reach out to you guys and help you out. So Discord would be the best way for you to contact us, assuming that you're using Gelato functions for the first time. But once, let's say you have like an actual product, then maybe we can create like a Telegram group and give you dedicated support there as well. So yeah, Telegram and Discord would be like the best way for you guys to reach out if you're starting out with Gelato for any product, let's say. Yeah.
Great, nice, thank you. And I guess my last question to you would be, so as we hear, Gelato is very busy releasing new features all the time. So we hear new things coming up, which is super exciting. So For those who are actually interested in maybe building with you rather than building using Gelato, do you accept community contributions? Is any of the code for the project open source? And how can folks get in touch if they maybe have some feedback or feature requests if you want, or just want to get involved in that way rather than just building with the tools?
Yep. So all our code is open source as well. For all our services, this includes, at least for Rootstock, this would be Gelato functions, Web3 functions, Relay, as well as PRF. All the contracts are, open source as well, so you can take a look. If you would like to, create, say, add like a feature or something, obviously, like I said, best way would be to reach out via Discord, and that's where we're active. And yeah, you can take a look at the code. We do have a few people, sometimes making pull requests and, adding something that they might think that makes sense. So that's something we take it internally and take a look at that, if we have to, we can merge it or not. So yeah, obviously that's the best way. Take a look at the code. It's all open source, and yeah, reach out to us on Discord if you need any help.
Nice one, sweet. Well, thanks so much for joining us. Really enjoyed it. Lovely examples. It really makes it look super easy for folks to get started. So for those who have been watching, as Anya just mentioned, if you have any questions, do ping him. He's pretty active on Discord, so do join the community if you haven't yet so done. So join the Rootstock community as well. And it was great to have you, Anya. Thanks for joining, and happy building to everyone. See you soon.